Expand the following function in Laurent series. F of z is given by 1 by z minus 1 into z plus 3 for 1 less than mod z less than 3. First of all, Laurent series. Laurent series is always defined for deleted neighborhood of singularity. That means we have a center A and circle with center A, and the Laurent series is always defined for the annular region. That means deleted neighborhood of A. This is neighborhood of A and deleted neighborhood of A. This annular portion f of z is always analytic and A is singularity of the function, or else f of z has singularity in this region. So f of z is always analytic in the annular region and Laurent series expansion is always valid for this annular region. So here we have 1 less than mod z less than 3. That means we have a circle with a center 0 and first circle is with the radius 1 and minus 1. Radius 1. This point is minus 1. And second circle is mod z less than 3. That means 0 centered 3 radius circle. This 3 and minus 3. Clearly this function has z is equal to 1 and z is equal to minus 3 are singularities. So this is minus 3 and z is equal to 1 is here. So the series, the region is given by this region. That means mod z greater than 1 and less than 3. This is the annular region, and we can always find a Laurent series expansion for this function f of z in this region. So first of all, we can write f of z as f of z is equal to, this is 1 by z minus 1 into z plus 3. We can write it as a by z minus 1 plus b by z plus 3. So that is 1 by z minus 1 into z plus 3 equal to a into z plus 3 plus b into z minus 1 divided by z minus 1 into z plus 3. And this term cancel. So 1 is equal to a into z plus 3 plus b into z minus 1. Now let's find a. For that, put z is equal to 1. So this is 1 equal to 3 plus 1, that is 4 into a. That means a is equal to 1 by 4. For b, put z is equal to minus 3. So that we get 1 is equal to minus 3 plus this is 0 and minus 3 minus 1, that is minus 4b, which implies b is equal to minus 1 by 4. So this is equal to 1 by 4. 1 by 4 we can take it as outside. This is common. So 1 by z minus 1 minus 1 by z plus 3. Okay. So the function is now 1 by 4 is into 1 by z minus 1 minus 1 by z plus 3. Now let's identify the region. This is mod z greater than 1. Mod z greater than 1. That means, or this is 1 less than mod z. 1 by mod z is less than 1. 1 by mod z is less than 1. This is 1 less than mod z. 1 by mod z is less than 1. Also, this is mod z less than 3. That means mod z by 3 is less than 1. So note this region 1 by mod z less than 1 and mod z less than 3. This is our valid region for the series. So here 1 by z minus 1 and 1 by z plus 3. So f of z is now 1 by 4 into 1 by z minus 1 minus 1 by z minus 3, z plus 3. The region is 1 by mod z less than 1 and mod z by 3 less than 1. Okay. Now this is 1 by 4. This is 1 by, we want 1 by mod z. So take z outside, we get 1 minus 1 by z. Now here we want z by 3. So take 3 outside, we get z by 3 plus 1. So this is 1 by 4, 1 by z and 1 minus 1 by z. 1 by 1 minus 1 by z. Always remember geometric series 1 by 1 minus z and 1 by 1 plus z. This is 1 plus z square plus etc. which is valid for mod z less than 1, and this is 1 plus z, so alternative plus and minus 1 minus z plus z square minus z cube plus etc. This is also valid for mod z less than 1. Always remember these two series for this. This is 1 by 1 minus 1 by z. 1 by 1 minus 1 by z. Instead of z, we have 1 by z here. And also 1 by z, modulus of 1 by z is less than 1. So we can use this series. For mod z less than 1, 1 by 1 minus z is 1 plus z square etc. So for mod 1 by z less than 1, 1 by 1 minus 1 by z is 1 plus z is 1 by z and z square 1 by z all square and z cube 1 by z all cube plus etc. Next term minus 1 by 3. This is 1 by 1 plus z. 1 by 1 plus z. Instead of z we have z by 3. 1 by 1 plus z. This series is valid for mod z less than 1. We have modulus of z by 3 is less than 1. So we can use this formula, that is 1 minus z. Z is z by 3 plus z square, z by 3 square minus z cube, z by 3 cube plus etc. Now this is 1 by 4. You can take z outside, 1 by z inside. This is 1 by z, 1 by z square, and here this is z square and into z is z cube plus 1 by z raised to 4 plus etc. Next term is minus 1 by 4 into 3, that is 12. 1 minus z by 3 plus z by 3 all square minus z by 3 all cube plus etc. So this is the series 1 by 4. We can write it as series n is equal to 1 to infinity. Since we start with 1 by z, so n is equal to 1 to infinity, 1 by z all power n. And next one is minus 1 by 12 series n is equal to, this starts with the 1, so I put 0 to infinity. Also there is alternative plus and minus, so this is minus 1 power n z by 3 all power n. So that the first term is 1. Minus 1 power 0 is 1 and z by 3 power 0 also 1. Next term negative z by 3 and so on. Also we can write it as, this is n equal to 1 to infinity. 1 by z raised to n. That means we can write as z raised to minus n, or we can write it as 1 by 4 into series n is equal to, I reverse the sum. That means minus infinity to minus 1 z raised to n. I reverse the sum, so 1 by z becomes z. Z raised to n. That is, this first term is z raised to minus 1. That means 1 by z. Then 1 by z square and 1 by z cube. And these two are same. Next is minus 1 by 12 series n is equal to 0 to infinity minus 1 power n z by 3 all power n. So this is the Laurent series expansion of the function in that region.